I'm Nathan Studer, and I'm going to be talking today about certification in Xen, and Robbie Van Vossen is going to be giving a short interlude on some certification metrics. So certification in Xen. A lot of people here are cloud providers, and they use Xen in commercial space, so we must be at the wrong conference, right? But really, you should actually care about this stuff, because people are trying to use Xen in the automotive world, and we particularly are trying to use it in aviation. And I want you to think about it for a second. Think about what it would take for you to get off the airplane that you took to get here this week. And I know something that would get me off the airplane is if the pilot said, okay, everybody, we decided to replace all our expensive and fancy equipment with Windows machines, with Dell machines running Windows. I would be off that plane in a heartbeat. It would take an air marshal with a very large gun to keep me on that plane. And I hope that everybody else would be jumping off as well, pretty much because everybody has had this experience with Windows. Windows can't be trusted to run cat videos online, so why in the world would you ever trust it to run your airplane? And really, when you get down to it, that's kind of what certification is about. It's about trust. All the certification standards that automotive and the aviation use are assurance standards. Kind of what this means is that you have to demonstrate that your process to build the software will catch most of the bugs. It's obviously not possible to catch all the bugs, so this is kind of something you have to do. And usually you demonstrate this trustworthiness to a government body. People tend to trust the government in general, so then they tend to trust your software. And it's really important because in general, for server domains, if something goes wrong in a server, it can ruin your life. Something bad can happen, but really unless it falls on you, it can't actually hurt you. But with a car, the car can crash, the plane can fall out of the sky, the robotic surgery could go haywire and kill everyone in the room. So really it's important, and we especially think it's important that these type of systems have open source solutions, because it's kind of disconcerting when you have to trust your life in this little black box that you really don't know what's going on under the hood. So this is just a brief outline of what we're going to be talking about today. Basically what the motivation for this was, and kind of what's a really quick overview of what certification is, and how we're going about certifying Xen. Our work started when we noticed some similarities between Xen's architecture and a special operating system in aviation known as the ARINC 653 operating system. And basically their underlying software architectures are almost identical. So it was just an easy fit. So we started to add some ARINC 653 extensions to Xen. First, one of the most visible ones is the ARINC 653 scheduler, which we did upstream. Based on this work, we submitted several proposals for some Navy small business research grants. They're not called grants, I apologize. They're just topics. In partnership with Rockwell Collins, which does a lot of formal methods work, and an FAA representative, which is called a DER. The main goals were first to actually put Xen on a system, a prototype system, and show that Xen could actually run one of these safety critical systems. And then to just start kind of thinking about how you would go about certifying Xen and what it would actually take to do this. And to just begin the certification process and do some formal methods. And we do have some interesting things to say about the formal methods work, but really this talk today is primarily about the safety certification, DO 178. Oops, sorry about that. Certification. So in general, certification requires things that everybody in this room knows should be done, but they tend to kind of ignore. And the best example is documentation. When you run out of time, documentation goes out the window, next goes testing, so on and so forth. But certification requires that you do this. It enforces good practices. Basically, the biggest one here is that you really shouldn't, in a perfect world, test what you write. And certification requires that there's at least some independence. There's some very curious verification activities that certification requires that we won't really get into here. And then the big one is there's a bunch of language in the standards to prevent some loopholes to certification. And one that really trips people up is tool qualification. And I'll admit certification can be a lot of mundane, repetitive, processes that really no one wants to do. And it's a normal software engineering response, and it's a healthy software engineering response that you would automate these processes. But then the problem is, what if this process you automated now introduces an error, which ends up in the airplane, and the airplane crashes? So there's actually, DO-178 has a 100+ page appendix completely dedicated to this topic. And what it boils down to in the end is that you have to certify your tools as well. Usually you don't have to put as much work into it. You can certify them to a lower level. But this is something that really trips people up because they want to automate everything. And you kind of have to carefully weigh what is really worth automating in this. This is just a brief overview of kind of each. So yeah, DO-178 splits software into 5 levels, level E through A, based on how likely the error is to occur and what kind of things will happen if that error does occur. And certification requires additional things at each level, and this is just kind of a brief overview. And some research has been done to relate DO-178 to the ISO 262, which is the automotive standard, and they're basically equivalent except in reverse letter order, which is just incredibly confusing. As an example, a level E application might be infotainment. If infotainment display goes down, you miss the end of the World Cup. It's a terrible travesty. You won't be able to talk about it with your friends. But in the grand scheme of things, did it really matter? And no, the answer is it didn't. A level D, level C application might be an instrument. If the speedometer goes down, I know for a fact that you can use the RPM gauge in a pinch and just kind of follow traffic. So you can mitigate some kind of instrument failures, usually in your eyes and ears. And then level A and level B might be engine, or usually the best example is engine. Engines go down, plane falls out of the sky. It's pretty obvious that that needs to be the highest criticality level.
So our partner, Rockwell Collins, performed a study in 2009 to actually get some metrics on how long it really takes to certify code. They based these numbers off project size, so source lines of code, and they basically found that the more stringent the level, obviously the longer it's going to take, but found these exact numbers. More interestingly is without certification experience, you need to multiply by about a factor of 4. So that ends up being more than 2 hours per a single line of code for level A certification. So to see how this affects cost, we made some assumptions. We used a rate of about $100 per hour and looked at 2 different code base sizes. So we looked at 30K SLOC, which is approximately the size of Xen on ARM, and then 1 million SLOC, which you could maybe get a small kernel out of that. So when you start looking at the figures, you see that to level C at 30K, it's still reasonable. You're below 1 million or in the low millions. Then when you start getting up to level A, you start getting almost up into the 10 millions. Then when we get to 1 million SLOC code base, it gets a little more unreasonable. You're in the much higher tens of millions. And then with level A, it's astronomical, hundreds of millions of dollars. And then an interesting note is that for the inexperienced, it would take about a team of 1,400 people to complete this in a year. So where does all this time go? If we already have the source code for Xen, it seems like this shouldn't be that big of a deal. But if you look at the graph, you see that source code is actually only one of 66 objectives within certification to level A. So there's a lot of other things in development, verification, and a huge one is verification. So SLOC is kind of a misleading measurement, but all these things go for each line. So certifying core Xen, as you can see, cost increases with SLOC size. So the general plan is to basically create a small working subset that would take out any functionality that you wouldn't need or necessarily want on a flight system, such as code for debugging. This turns out to not be as easy as you would think. We attempted to do this, but without much knowledge of everything we would need for our flight system, kind of halted our work on that. The next step would be reverse engineering any certification artifacts for features that already exist. This has some difficulties that we'll talk about later as well. And then obviously forward engineering any new features. And then this is interesting since we're working on an open source solution like Xen. We would like to be able to push those out to Xen as long as they fit with the path. And then again, on the same thing of reducing code base size, we'd like to use virtualization extensions. So you want to rely on the hardware as much as possible to really limit the size of your code. I'll put it back to Nate.
There have been successful reverse engineering certification efforts before. So many so that CAST, which is the Commercial Aviation Safety Team, they're kind of a group that writes position papers on certification. They published a paper about reverse engineering, and specifically the kind of things that can go wrong when you attempt to do reverse engineering with certification. The first one doesn't really apply so much to Xen because Xen has a very good justification. It's used very successfully in the commercial industry, and it has a very good service history. So it's very easy to justify why you would want to use Xen. The next two really don't have much to do with the Xen developer community. They have more to do with the company doing the certification. But the last two, the Xen developer community does have some effect on, and so we wanted to touch on those a little bit more. This is the quote from the original paper, and basically it says, if you don't have some access to the original developers, you're going to be in a lot of trouble. You could be in a lot of trouble. But thankfully, we do have access to the original developers. At least on the ARM side, it's pretty clear that we do. On the x86 side, Keir Fraser is still around, and there are some very smart x86 people on the list, but the original authors aren't really as involved as they once were. And as anyone who's been on the list knows, Ian Campbell has about a 3-question per week limit before he cuts you off. So you're going to need you're going to need a backup plan. And once again, this is where Xen's open source model really helps out, is because all the patches that go into Xen have been discussed thoroughly on the mailing list, and you can see everything that went into making that patch. And you can even get a hold of the Git repo, and you can use Git blame to kind of go back in time and figure out how that patch came to be what it was. But once again, some of the earlier x86 patches, this isn't necessarily true for. They don't have very good commit messages, and they were basically just thrown into Xen because they worked, and that was about the only criteria for getting into Xen at that time. And then this is once again the quote from the original paper, and this is a pretty common complaint about open source software, is that it's very complicated sometimes, and it's not documented well. It's a recurring topic on Slashdot. It even showed up last month, and there's not really much we can say about it. It's a common complaint. There's nothing we're going to change any day soon, probably. But kind of what this is leading up to is pretty much that if we're going to certify any part of Xen, it's going to have to probably focus on ARM. x86 at this point is probably a lost cause. It's just going to be too difficult without access to the original authors and with some of the older and very complex codes, such as the PVMMU code. But we did want to at least give an example of what a good patch would look like from a certification perspective. And I've been holding on to this patch for a long time because it was so good. This is patched by David Vrabel for scalable event channels. And it's got a pretty nice introduction, but then it has this attached markdown document. And this markdown document has an introduction, just an overview, and then it has some high-level design details, which is good enough for a level D application. But then even better, we have low-level design information, which is good enough for a level C, B, or A level certification effort. And really, this is an absolute perfect patch. I don't know why he did it, but he did it. we could take this document as is and just stick it into a certification package. There isn't any documentation on testing, but really, we can't expect David to do all our work for us, though it would be nice.
60 cents a line of code you are?
So far, we've pretty much talked about the core of Xen, which is pretty small, but everybody here knows that Xen depends on some other things to make it work, and these kind of need some special considerations. Obviously, for all of these, we could do the same approach. Make a very small subset, small as we possibly could, and then try to reverse engineer all the certification artifacts. But like is in the case of the bootloader, really in a safety critical system, you only need it to do one thing, boot from one source. You don't need all the fancy bells and whistles that U-Boot provides. So you probably just want to use your own very simple bootloader that you can easily certify. QEMU. QEMU provides emulation and some PV drivers. But we really want to keep, if we have to use QEMU at all, we'd like to keep that as small as possible, which puts some constraints on what kind of I/O we'd like to use. Pretty much direct pass-through is absolute best. That way we don't add any code that we need to certify. And if we do have to add some extra code, it should be PV, pair virtual drivers. Those are pretty simplistic, usually more simplistic than an actual hardware driver, and even more simplistic than usually an emulation layer, so they're easier to certify. If we have to use emulation, we have to use emulation, but we probably would like to avoid it if at all possible. And then we get to the tool stack, libxl, and it's a very nice tool stack. It has a lot of features, but there's some features in libxl, such as the garbage collector and asynchronous operation, that keep certification authorities up at night because they introduce all kinds of non-determinism into the system. So once again, as with the bootloader, most safety critical systems have very static operation, and they don't need to be doing all the things that libxl has in it. So really, we probably want to just create a very simple tool stack that does the bare minimum, no more, no less. But then DOM0. DOM0, it is basically Linux. So the question becomes, how hard is it to certify Linux? And it has actually been done before. It's been done for level D applications. But most people who work with certification think that moving to the next level is going to be very hard. Usually people guess that it must be because of the rate of change of the Linux kernel. But we've done some looking into that, and we found that really a lot of the changes in the Linux kernel are contained in the periphery, more in the drivers than really the core kernel. So it's not that big of a deal. If we look at what level D and level C actually require, you can start to get a picture of why it's such a big hurdle. Level D requires basically high-level documentation as well as some functional test. You can go buy a book on Amazon that tells you how Linux works. And functional tests are pretty easy to write, So most of this information really already exists or is easy to generate. Level C adds statement coverage, but you can get 80% statement coverage with a Hello World program. So that's not too difficult. Code and data coupling analysis, we're not going to get into what that is, but it could add some testing effort. But then it's the last two that are the big ones. How would you, as a community, like to provide all of the low-level documentation and unit testing for the entire Linux kernel? And the answer is you wouldn't. It seems like almost nobody does. These are extremely unpopular tasks in the open source community. So anybody who would like to use Linux for a certified system at this level would have to basically fill in all that missing information, which is a serious undertaking. So don't tell the people down there at the end of the hall, but we're probably going to want to replace or avoid Linux if at all possible. But we'd like to remain as open source as we can. Some possible ideas might be to build up mini OS to the point where it could be used as a DOM0. Similar idea with free RTOS. You could, of course, write your own DOM0, but why would you want to do that? But then there's then another route, if you're willing to sell your soul to Wind River, is to use an already certified DOM0, such as VxWorks and then buy their certification package so you can just avoid the Linux problem altogether. There's some hybrids of that approach, and this is where Xen's disaggregation feature really is a great selling point for Xen, is you can basically try and push off as much Linux functionality as possible into disaggregated domains that have an actual certifiable operating system in them. And then in talking with the unikernel people yesterday, they're pretty sure that we can push basically everything out of Linux and into a unikernel instead, into disaggregated unikernels, which would be ideal. Just a brief note on cost. Obviously, based on the slides Robbie showed, it's going to be expensive. So any company certifying Xen has to find some way to amortize the cost over several projects, several customers, something. Just a general idea of how best to go about that is usually just to start with something less critical, such as an infotainment system. Once you're on an infotainment system, then you can start to build up to the higher levels. Not only does that get you practice at certifying things, but it also builds you up some service history. And if you can go to the FAA and say, well, my infotainment system is running in all these cars and it never crashed, they look on you with a much better light when you go up to the higher levels, and they don't give you such a hard time. So really, in conclusion, and we're not really sugarcoating it, it's going to be a lot of work. But we personally, and many others, think that it's important to be done and that Xen is a really great starting point to do it. And these are just our references if anybody wants to look them up later. And then I'll open the floor to any questions.
So why not use, for example, Green Hill software for some of this already that is probably already happening now? Is it just because they don't have a RN with a RN 653 schedule? Or?
So the question is, why not use Green Hills?
Yeah, or any other commercial products that are already out there?
Green Hills is very expensive, number one. It's not open source, number two.
Right.
And this is a big deal because kind of how it works is these platforms, obviously, we're saying they're static, but that can't possibly be. They do eventually change. And when they change, Green Hills is more than happy to sell you an entirely new license for the software. So open source software is very attractive in that way, where Green Hills and Wind River are not.
Okay. So it's more about the long-term approach. You think that you're bleeding money out to commercial companies, but with open source, there's an initial investment and then it's free.
Not necessarily free. You know, somebody has to provide the services to update it still, but less expensive than, say, Green Hills might charge. And like so obviously we did the work with the Navy. They're very interested in this idea because they're kind of tired of being, shackled to the Wind Rivers and Green Hills of the world, and they have some pretty smart people working for them, so they think they would like to be able to update their own software.
So do you see any benefits for sort of the more server use cases and so on if we moved in that direction?
So what's the question again?
Like say you guys do that work, and then obviously there probably will be some benefits for the wider community as well. Particularly the traditional use cases which Xen was developed for.
Yeah. So.
And what would they be?
I don't know about the server community exactly, but some of the reliability things are being looked at for the safety critical domains. So kind of, it's very similar to the server stuff. We have on the airplanes, we have redundant systems. Something fails, you want to move it over and bring it up on a different system. Right now, these are very, very static things. It'd be really nice if we had something more like you guys do in the server domain, where you can be more proactive about moving things around.
So you showed the price of the certification of each line of code.
Mm-hmm.
Right? Is that based on the Xen source code, or basically based on something you don't have the initial ownership, or based on something you have ownership already?
It's not, and there obviously are some cost savings because the source code does exist. You don't have to go through that work of trial and error to eventually actually find a solution. So that does save you some time.
Have you looked at any of the other types of certification? I mean, A-Rank is like almost a worst case certification, right?
It is.
I live in the embedded controls world, so I mean, like, I do traffic light controllers, and you're trying to get a new version of software OS certified for a traffic light controller takes months.
Yep.
And that's without going through a lot of the stuff you're talking about. I mean, just the simple testing takes forever. You'd be surprised what kind of issues come up if you get two green lights in opposite phases going. But I mean, there are other standards out there, and I know some of the standards, it's like, okay, well, you've been through that, and we'll accept some of that documentation toward this. Have you looked at any of these other testing and certification standards to sort of start building a base of certifications for Xen?
Part of the, yes, that'd be, and that's kind of what the point I was getting at with the moving from level up the levels, because you can't really certify software. You can only certify an actual system. So your software actually has to be on a plane to be certified. So it's kind of a chicken and egg issue. You have to convince somebody to take the opportunity on the software. So that's kind of, it's easier to convince somebody to test unproven software in the infotainment system than it is to fly the plane.
Like Rockwell uses my software on their infotainment systems now. I mean, I like collecting their checks every quarter. So, you know, the infotainment systems, the certification is basically does it work.
Yep.
Whereas I know like traffic light controllers or some of the stuff I've done like in lights out factories, they get a little bit more antsy about how well does this thing happen and what happens when there's a fault. I mean, it's not so much they expect perfect operation, but it's like what happens when if there's a fault, do you fail in a safe manner? And so I'm wondering if you've looked at any of those.
That's more on the systems level, but we can obviously talk about it more after this conference. But what you've been saying has kind of made me think about Lars' original question is what might the benefit be to the larger development community is Robbie pointed out how much verification there is involved. And all this verification would naturally flow back and make Xen a more robust, more secure product in the server space as well. That's probably the biggest benefit.
Also, in our initial investigations, we found that, you know, when we started doing formal analysis, Rockwell Collins was really happy that we were so focused on safety because that kind of lends itself to security. So you may end up with a more secure system in the end.
Yeah, you tend to find things tend to build on each other real quick, especially in the embedded world.
So if there's no more questions, we'll finish up. Thanks.
Thank you.